Students, now this is the third session for the revision of end of term final exams. I'm going to share my screen with you. So we are going to start with further integration. So further integration is related to partial fractions. So students needs to know how to do the partial fraction first, and then they can solve the integration. So few things about partial fractions. As you can see here, we have here two factors, and two factors in the denominator, right? And both factors are linear because the power of x is 1. Linear, 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 linear. So a student needs to know how to convert any fraction into partial fractions when we have denominator is containing only linear factors. So I'm going to explain you guys first. If I have 7 over x plus 3 and 2x minus 1. I'm trying to do the first part. So since I have two linear factors, I'm going to split it into two partial fractions. So 2x plus 3 plus b over 2x minus 1. The challenge is this, that I need to find the value of a and b. The rule which I like to apply in partial fractions only for the linears, you put, if you want to get a, under a, the factor which is given, put it equals to 0 and get the value of x. Same thing if you want to get b, since b has a linear factor in its denominator, put it equals to 0. Now, these two values will help us to get the value of a and b. How? You need to focus on your left hand side. To get a, you have to plug this value in the place of x. Please don't substitute here, because if you substitute it here, the denominator becomes equal to 0. So it's the hide rule, and when you plug on the left hand side, you need to hide x plus 3, because if you put over there minus 3, it will make the denominator 0. So rather than putting this value minus 3 into the first factor, I'm going to put it into the second factor in the place of x. Wow. So it gives you 7 over minus 7, which is minus 1. So a is equals to minus 1. This is the direct method which I love to apply for students. Now I have x is equals to half. I want to get the value of b. Can you guess what I'm going to do now? And now I'm going to plug it in x plus 3, not in 2x minus 1, because 2x minus 1 will become 0. So in the place of x, I'm going to put half plus 3. It becomes 7 over 3.5, which is 2. So I got b is equals to 2. Bravo. So I got a and b. Now I'm ready to do the integration of 7 over x plus 3 and 2x minus 1 d of x. This is minus 1, integration of minus 1 over x plus 3 plus 2 over 2x minus 1. Now the same method you will apply. Yes, Ahmed. Now I'm just recording my video for 12A2 students. Yes, please. Oh, no problem. No problem. No problem. You can, inshallah. Thank you. Assalamu alaikum. OK, so now why I wrote, guys, the integration of minus 1 over x plus 3. You remember that in integration we studied, if you have here a linear factor in the denominator, we can write it as ln of, but you need to confirm you must have a linear factor in the denominator. Its integration is a of ln of ax plus b divided by the coefficient of x, which is a. That is the technique which you studied earlier. I'm going to apply that one here. So minus ln of x plus 3 divided by 1 because the coefficient of x is 1. Plus 2 coefficient ln of 2x minus 1 divided by 2 because the coefficient of x is 2 plus c. I'm going to cancel 2 with the 2 and my answer is minus ln x plus 3 plus ln 2x minus 1 plus c. So the same technique, guys, we can apply it for the B and the C part, and I'm not gonna do the B and C. This was the basic theme behind the solving of partial fractions when you have in the denominator two linear expressions. Next question is this. We have linear and linear repeated. I'm gonna solve the C part. Can you check, guys? I have a linear and a linear repeated. And x minus 3 is multiplying how many times? 2 times. So we need to know the partial fraction of these type of functions. Now I will get 3 partial fractions. A over x plus 1 plus b over x minus 3 power 1 plus c over x minus 3 whole squared. Basically, for this, we wrote 2 partial fractions. And for this, we wrote only 1 partial fraction. But we have to get the value of A, B, and C. With my direct technique, which I have taught you, will help you to get A, put x plus 1 equals to 0. X is equals to minus 1. Don't put this one 0 because you can put either one of them equal to 0. So here x minus 3 should be giving you the value of C. Ready? So I'm going to get the value of A. Don't put it in the first factor. Guys, A is equals to 1. We found it. Now we need to get the value of B. Well, so we got C is equals to 12. After getting the value of A and C, now we need to find the value of B. To do this thing, I have to multiply. I have to multiply here something, here, here, and this is the rule. Which thing I will multiply? I will multiply x plus 1, x minus 3 whole squared here. Now x plus 1 cancel with x plus 1, x minus 3 cancel with x1, x plus 1 cancel here, x minus 3 with one of them, x minus 3 cancel with both of them. Now, what is left to me? I'm left with 8x plus 24. A is 1. So I have x minus 3 whole squared plus b, x plus 1 left, and x minus 3 left, plus 12, and x plus 1 left. Now you have used already x is equal to minus 1 and x is equal to 3. You can use any other value in the identity. The most likely value which we love to use is x is equal to 0. Since it is an identity, any value of x can satisfy this above equation. I call it horizontal equation. We converted the fractional equation into the horizontal form. So in this form, I'm going to put x is equals to 0. So it becomes 24. So b comes to us minus 1. Now substitute all the values. Ready to do the integration? I'm ready to do the integration. So what is a? A is 1 over x plus 1. B was found minus 1. And plus 12 over x minus 3 whole squared. Such type of questions. I'm ready to do the integration for that. The first one, its integration is ln of x plus 1. This one, ln of x minus 3. Here the problem happens. When you have a power, you have to apply the power rule of integration. You have to send it on the top and then apply the power rule. Maybe in AS level, you took it minus 2 plus 1 is minus 1 over minus 1. So that integration is minus 12 x minus 3 raised to minus 1. And that's all. So guys, I have explained you the linear repeated also here. This one, you can leave it for this exam because improper partial fractions, they are not very important. Other than that, I will request you also get expertise in these type of questions like x plus 1 over x minus 1 and x squared plus 1. What I want to tell you, this is linear and this is quadratic, which you already took it. Linear and quadratic. How to write the partial fraction for this? X plus 1. Your teacher must have taught you. That is a over x minus 1 plus bx plus c over. This is the difference. You have a quadratic factor. You need to write a linear factor on the top. Now, as per the rule, you can get a directly. Now I need to write the horizontal form. You remember, I need to multiply here, here, and here. This vector. I can easily write my expression. After writing the horizontal form, which value of x has been already consumed? 1 is consumed. Can I plug here x is equal to 0? Because it is an identity. So it will give you c is equal to 0. Now, can I use any other value of x? Since you have used x is equal to 1, x is equal to 0, can I use x is equals to 2? And substitute again into the horizontal form, which is shaded blue. So b is coming to me -1. Now, can I plug all the values here? 1 over x minus 1, and the b is -1 x plus 0 over x squared plus 1 and dx. Am I ready? Yes, the integration of x minus 1 will be ln of x minus 1. And what is the integration of minus x over x squared plus 2? Guys, you remember there are important formulas which you studied. If you have a function in the denominator and the function's derivative is in the numerator, answer is ln of f of x. Now, what's the derivative of your function? The derivative of my function is 2x. Am I having 2x on the top? So what I will do, I will write here plus 1 over 2, and I write the -1 outside. Write the -1 outside and multiply the 2 inside, 2x over x squared plus 1, to make sure that the derivative is on the top. Now I'm ready to do the integration of this function as well, which is copy it ln of x squared plus 1 plus. Guys, you need to be very good in the integration rules. Another important thing in integration is when you want to do the integration and you have a squared plus b squared x squared. In this case, you have to know the formula, which is not in the MF19, AB inverse tan of bx over a. Suppose here you see 4. Take the square root. So your a is 2. Here is 1. Take the square root. So b is 1. What is b? 1. Square root of 25. A is 5. B is 1. A is 9. Bravo. I'll try to use the formula, which I wrote it here. I'm writing it on the top. For your reference. So what is the answer? 1 over AB inverse tan Px over A. 1 over AB inverse tan. Oh, there was a number here. Sorry. There is a number 5. So I need to copy it here 5. Yeah. So x over 5. There's a number here 9 over 9 times 1 inverse tan x over 9. So my final answer 1 over 2 inverse tan of x over 2 plus c. 5 cancelled. Inverse tan x over 5 plus c. 9 cancelled. Inverse tan x over 9 plus c. These are the same type of questions. A is 2, B is 3, A is 3, B is 4, B is 7, A is 9. Answer is 1 over 6 inverse tan 3x over 2 plus c. Answer is 1 over 12 inverse tan 4x over 3. Answer is 63 inverse tan of 7x over 9. Didn't I tell you when you want to make the derivative on the top? So what's the derivative of the function? It's the derivative is 3x squared. What's the derivative? 2 cosine 2x. What's the derivative? 2x minus 4. So how can I manage it? I have here 6, so I need to make it as 3. So take the 2 out and write here 3x squared over x cubed plus 1. Now you will say, Mr. Omar, I have the derivative on the top. This is just adjustment which I'm going to make. 2 is missing. Divided by 2, multiply with 2. Now you have the same thing in the numerator. So answer is 1 over 2 ln of the denominator 1 plus sine of 2x, and here ln of x cubed plus 1 plus c plus c. What do I need on the top? 2x minus 4. So divided by 2, so 2x, and this 2 will become 4. So it is equals to half ln of x squared minus 4x plus 3 plus. Same type of questions. What's the derivative of the denominator? It's 6e3x. The derivative of the denominator. It's 2x. The derivative of the denominator. No, we have to write it as cosine of x over sine of x. Come on, what is the derivative of sine of x? It is cosine of x. Am I having here 2x on the top? So divided by 2, multiply 2. Am I having 6 here? Divided by 6 and multiplied 6. Once you make sure you have the same things here. Now my answer is 1 over 6 ln of 4 plus 2e3x 1 over 2 ln of x squared plus 4 ln of sine of x plus c. Now we come to the integration by parts. In integration by parts, we have first part is x e raised by 2x. Before I go further, I want to explain you integration by parts is basically the product rule of integration. You need to make two boxes. In between the two boxes, you have to write a negative sign. One box is without integration. The second box is with integration. You have to split your boxes into two parts. Here, this is my first part, and this is my second part. Okay, so first part is that one chosen whose integration is not possible. So this is u, and this is u prime. And here I will take the integration of v and integration of v. This is the rule which I will always apply for integration by parts. It's not given in MF19, but in a different way it is given. So let me write a question. 4x e raised by 2x. This is u, this is v. What is the formula I told you? U dot integration of v minus integration of v dot u prime. This is the formula I have taught. So what is the derivative? Here I'm going to write u as it is. What is the integration of e raised by 2x? E raised by 2x divided by 2. E raised by 2x divided by 2. U prime, the derivative of 4x is 4. 2 cancel with 4. 2x e raised by 2x. 2 cancel with 4 is 2. Integration of e2x is e2x divided by 2 plus c. And finally, I'm going to write 2x e2x 2 cancel plus c. Let's do the b part. B part again. This is u and this is v. U dot integration of v minus integration of v u prime. Okay, what is u? U is 3x. Integration of sine 2x is minus cosine 2x divided by 2 minus cosine 2x divided by 2, and the derivative of 3x is just 3. I'm going to erase this on the top. What's next? Minus 3 over 2 x cosine of 2x plus 3 over 2 integration of cosine 2x is sine 2x divided by 2 plus c. Like that. I'm going to do the c part. C part is integration of 2x plus 1 e raised by x p of x. Let me make the two boxes. U prime integration of v integration of v. U as it is. This is u and this is v. Integrate derivative of 2x plus 1 is 2. Integration of ex is ex. and integration of Ex. That's all. The C part is done. Let's go to the D part. UV, U dash, integration of V, integration of V, that's the integration of this one. So now we come to the E part. U prime, integration of V, integration of V. Okay, U divided by 3, divided by 3. Like that. Now we come to the F part. It's a different thing, which I want to highlight here. Whenever you see ln, ln cannot be taken as V. This is well understood because integration of ln V, it is not commonly known. So that's why it is always U and this is V. This is the difference. You need to keep it in your mind. Let me make the boxes. U prime, integration of V, integration of V. Now U is ln of 5x, integration of 5 ln of 5x, 1 over 5x, sorry, derivative. Reciprocate the argument, and the further derivative of 5x is 5. Integration of x is x squared over 2 and x squared over 2. 5 cancel. So you got 1 over 2 and x cancel with x squared. So you are left with the integration of x, which is x squared over 2 plus c. Final answer is that's all. F part. Last part, x tan inverse of x. This is G part. Likewise, tan inverse tan, its integration is not possible easily. So call it U and this is V. So in the two cases, you have to take the function as a first part or a U, ln and inverse tan. Make the two boxes. UV U prime. So inverse tan of x, the derivative of square root of 2, x squared over 2, and the derivative of inverse tan is 1 plus x squared, right? So half x squared inverse tan of x minus, it's not very simple. It has x squared on the top. It's 1 plus x squared d of x. You remember your teacher has taught you long division, x squared plus 1 of x squared. So I can write it as 1 minus 1 over 1 minus 1 over x squared plus 1. So half. It's not very important, guys, for this exam, but you need to be careful for the Cambridge exams. Integration of 1 is x, and this is inverse tan of x plus c, and that's all. We are done with integration by parts. I can do that, but for the final exams, you can leave the integration by substitution. So inshallah, some other time I will explain it to you, and that's all, guys. I got so tired, and I hope like this effort will be helpful for you to understand and do perform well, inshallah, in the final exam. Thank you. Bye-bye.